I haven't made a video 2 weeks. My name is Glenn, and today we're looking at bloody earthquakes in on the planet on the 1st of the 10th, 2024, so the 1st of October. And surprisingly, we don't have that many. So here we have the world map from the US Geological Survey. We can go to Australia. And no, we don't pronounce it Australia. We pronounce it Australia. Australia. Welcome to Australia. Ooh, and look at that. Looks like the Ring of Fire has quite a few earthquakes, but these ones, this is the 27th of the 9th, so it's a few days ago. The red one, I don't like the way it does that. Okay, the red one is the first new one, and that is Baraba. Never heard of it. Baraba. But the good thing about this is that it's satellite and you can check the actual location itself. So I see there might be some. Oh, yeah, there you go. You got fields. That looks like we've got terraces. So pretty much this earthquake centered here. Is it a flat plane? Yeah, it looks like it might be slightly undulating. So we were looking for Barra, New South Wales. We're just gonna see. Okay, what is the designation? So shallow earthquake. So the thing about geology in Australia is that all the rocks are faulted somehow, and a slight movement can actually cause a tremor. Now, that could be just the movement of the rock itself via gravity. It could be mining or dams that can actually impact and change the geology and also the stresses on the rock. Okay, let's look at Barra opening maps. So obviously it's been denuded of trees. There are some trees. Here's a watercourse, the Barra Creek. Yeah, we call these small little rivers creeks. Do we have any mountain ranges? No. Okay, here we have a dam. So this looks like an artificial dam. So yeah, there's the actual dam itself. So that's not natural. So building this dam itself will change the actual stresses on the geology because you've got a lot more pressure underneath this rock. You also got a lot of wear or erosion occurring along the lake shore. So that's going to change it. So there's actually lots of factors. Long arm. Okay, so it looks like we have a mountain range here. Mount Kapatua National Park. So I'm not too familiar with the geology of this area. So we go Barra, and you can see it's in the middle of a elevation. So that's very interesting. So, and I would say, okay, Google Maps wants to bloody work. Okay, this is probably part of a accretionary wedge at some point. I know all this has been accreted to the actual continent during one of the orogenic episodes. So the original edge of Gondwana would have been over here, and all this material's been accreted. So this would have been uplifted probably at least 300 to 400 million years ago, I would say. So basically, we have the national park, which wouldn't be cleared of trees. Yes, the national park's got a lot of trees, and here's another one. A lot of trees. Okay, so the earthquake is, where was it? Yeah, somewhere around here. Okay, somewhere around here. So, obviously, the United States Geological Survey doesn't care about Australia, which is really sad. Um, Longitude, latitude, blah blah blah. Indicators, refining stations, number of phrases used, blah blah. I'll eventually get around to explain that once I find out what they are. And here you got a lot of different information. Looks like different stations. Okay, got different stations, so definitely. Shape map, fuel grid. No, this is just all information about it. So it doesn't give too much information. So that's interesting. That's the recent one. Hope anyone felt that. Got one north of Canberra. That was 26. One north of, looks like Wollongong. Probably northeast, yeah. Oh, Warrnambool, not Wollongong. Should know that town. I go there quite often. Okay, and see, this is shallow as well. 5 kilometres. So this is pretty much just the surface geology moving. Yeah, shallow, 10 kilometres. So this is pretty much in the surface. I don't see any deep. So we're not too sure why these earthquakes occur in Australia. They're all shallow. If they were deep, it would indicate that there's some sort of convergent plate boundary. But Melbourne's not surrounded by a convergent plate boundary. This is probably an older plate boundary, no longer active. So this one would have been subducting under that one. But obviously not working anymore. This could have been a transform plate boundary, no longer functioning. Although we do have stresses going up and down the actual. So you got all these stress lines that are occurring. Yeah, sorry, spring. And that's why, yeah, spring, hay fever. So we've got divergent plate boundaries somewhere here. It doesn't show up on this. It's somewhere around there. And, oh no, here it is. Divergent plate boundary. And these stresses would be going through the actual continent itself up into the top. Because these separate at different times. So this one might separate 1 year. I know 5 years later this one does. It's pushing the actual rock up. And also, because it's subducting, it's also being pulled. So that would actually push-pull pressure on this rock. And it's only shown on the surface. So it's not very deep, it's just shallow. So the deeper rock must be fairly stable because of the high pressure and temperature. Okay, so we're looking at the current ones. So we've got one in Indonesia, and the one in Indonesia. I can change the map panel. Satellite. I always like satellite. And the reason why I like satellites is because it can show you the depth of the ocean. So here's all pretty shallow, and this is pretty deep. So, okay, but this one's pretty slow and actually. Anyway, so that one, see, 73 kilometers deep. So this is caused by this Pacific Indo-Indian plate diving underneath, and somewhere in the sphere, it's interacting with the mantle, and it's causing friction. So this will have. So that's why you have a lot of volcanoes, because all that magma is covered up here somewhere. And these are probably caused by accretion and uplift. Here, it's probably the back arc basin. Back arc basin, fore arc basin. So there's probably magna rising. And we use Papua. I'm not too familiar with those islands. Anyway, so that's that one. Would have been too much trouble, except it could have caused some tsunamis, but probably not. Okay, it seems like the United States has a few. So here we have one. Looks like it's in Texas. Oklahoma. Sorry, I should learn to read. Okay, it's 2.4, so it's not really big. These are all small. So, while they probably would have been felt, it would have not caused anything. Here we have a convergent plate boundary. So, this one is 10 kilometers in the actual Rocky Mountains. And this one is 30 in Washington State. Okay, and Alaska. So, here's another convergent plate boundary. Aleutian Islands, Alaska. So this one's 87, quite deep, but it's in the actual mountain range. So these mountains are actually still getting pushed and squashed. So I'm not surprised earthquakes occur here because there's lots of stresses. So these mountains are still rising and also sinking underneath because you need isostate equilibrium. So you need something to be equal, whereas if it goes too high, it topples over. So it needs to be well rooted, like your teeth. Actually, a lot of people's teeth are just screwed. Okay, here we have one close to the coast. It's deeper. And we have some information. So felt report, only 2 people responding. Okay, origin and magnitude. Magnitude, yeah, not really big. Origin, so you can put that in the location. Depth, 30 kilometers, plus or minus 7. So there's always a default local time. Number of stations. Phases. Number of times it's felt, 25. Travel time, 13 seconds. Minimum distance, 4.4 kilometers. Okay, so not that much information. Few nearby seismic activity. So here we have, okay, in Washington State, you can click on this and see all the previous earthquakes. That have occurred in the region. So as you can see, it's quite a lot. Okay, explosion. So the triangles are above ground and the circles are below ground. So I've got one in Vancouver near Victoria. So yay, lots of volcanoes. So here's the convergent plate boundary. Here we have the epicenter of earthquake. So this is all the mountain ranges here. And in this stable region continental crust, where the subducting plate is quite deeper, we have it just peters out. So the earthquakes would be fairly deep here. No, 7.7 kilometers, so there's something going on there. Let's have a look at that one. 3.8. Oh no, it's still shallow. These ones are deep. Not as deep as what I thought. Anyway, so this doesn't have any earthquakes currently, which is pretty normal because we're way away from the actual lake boundary. Okay, so Alaska, regional information. So you can click on this as well and see all the previous earthquakes, but you can't click on each individual earthquake, which is makes me sad. But it shows you so the larger the circle, the larger the earthquake. Okay, and that's basically it. click on this one for nearby seismic activity. You can see there is a lot of earthquakes in this region. So here's the plate boundary. Actually, it goes around there. So that's just for this region. So obviously they haven't put any information for here. This that plenty of earthquakes as well as the Aleutian Islands. But as you go up north towards Alaska, they would decrease. So that's very interesting. If you want to go to Alaska, live near Anchorage. It will be, shaking good. Okay. Then we have Cocos Plate. So we've got another one in Chile. These should be quite common. Only 4.2, so not really that big. And that one, 3.5 kilometers down, so definitely because of the convergent plate boundary. Okay. Look at nearby seismic activity. No one's reported it. Obviously, based on this graph here, we have, let me get rid of my face. Okay, so we have quite an extensive earthquakes. These will be shallow, grey ones will be a lot deeper. And we have okay, so this one's off the coast. Could cause a problem with a tsunami. Then we have another one. Okay, so this one, obviously, this one contradicts the previous map. So it doesn't have that many earthquakes, but how bad? Okay, if we go back to this one, obviously indicates it's quite an extensive array of earthquakes that have occurred in the region. All these were shallow, recent. Then you get in the mountain range a lot more deeper earthquakes. This one should be deeper. So that is interesting. And let's go to the border. Okay, so basically there's not that much earthquake activity today. A lot of these probably haven't been reported. Most of them in North America. Then we've got some. Got one off the coast of so there's El Salvador, so Guatemala, 4.6. Then we've got some around Puerto Rico. So Puerto Rico is part of a, looks like a, not too familiar. Looks like a divergent plate boundary as well as a subducting plate boundary. That would indicate why all this is has a volcanic origin. Okay, so yes, quite a few actually. So there's been recent activity, or mid, probably 15 to 40 kilometers, but the magnitude's been low, so you would have felt them. But the buildings on Puerto Rico should have been built enough. And it's close. More concerned about the Dominican Republic in that. Okay, Africa, nothing. Probably due to the lack of seismic stations. India, I would say the earthquakes will probably occur along this convergent plate boundary of the Himalayas. Not as many in the south. I'm surprised this Ring of Fire doesn't have earthquakes in Japan. No, none reported. Maybe I'll come back tomorrow and have a look. Anyway, thank you very much. Hope this helped you with your earthquake summary. Let me know what you would like to know about earthquakes and how I can improve these videos. Thank you and goodbye.